So we get to this point where we are going to transition from Python, although Python is a really good programming language, very popular and used in many different applications. We have options in terms of what you want to produce to submit to the AP, to the College Board for your AP exam. So you do have to create an application. You have to create something, a game, um, a simple game without graphics, with graphics. And the other language that we're going to choose to use, that I've chosen for us to use in the class, and so that you can have two options, is Scratch. And you can look it up, Scratch. It is scratch.mit.edu. It is still it is considered a programming language, although here what we consider this an even more abstract, a higher has higher levels of abstraction than Python, which means basically that it is simpler to use, simpler to code with. We don't have to worry about learning the syntax. This is block-based programming, and you can look through tutorials. Excuse me, that's my son. So there's tutorial videos that walk you through how to create something. The first thing we want to do is obviously join Scratch. So we go through the process here where we create a username. So here, O Ortiz 208, and then I don't want to show my password, so type in your password. If those they don't match, so you select your country. This is the United States, and when were you born? So your month and year. Gender. Email address. So for me, this might I conflict because I do have an account already, but you would put here your email address. I guess not. So we get started. Okay, great. So now that we're in, notice that it has my username right there, Ortiz208. And then there's messages here, basically probably a welcome message. Yep. Now we go to create. Well, this is where we create applications. And this is what we start off with. Notice here we have this window here where we have this cat, which we call sprites. This is a sprite. This is where you can see your program run. And then this window over here, this is where you're actually going to be dragging and dropping these blocks to have your sprite do something. For example, let's suppose that we just want the sprite to move to the right. Well, we can first go to control. Let's see, control here. Oh, events. And we say that when we click on the flag, we want to move our sprite 10 steps. Now it says move, and basically it's going to move in the direction in which it's facing. So if I click here on the flag, notice it moved 10 steps. We didn't actually quite see the motion because it's not a lot. 100 steps. Notice, and it moved instantly, which also kind of takes you back to Python and the fact that the processing speed of these devices is so fast that we barely see the motion. So let's say that we want to slow it down a little bit. By the way, you can always drag your sprite and place it wherever you want it to go. Or better yet, you can have it start at a specific location. So we can say go to, and we can specify here the X and Y coordinates. If we look at the X and Y coordinates right here of the sprite, those are current X and Y coordinates. If I put a 0, 0, then anytime I click the flag, it's first going to go to that location, 0, 0, and then it's going to move 100 steps. However, we don't see the motion. So how do we slow this down? Well, we can use a looping mechanism where now we can go in here to control, and we can say repeat or do forever. So I'll do a repeat. Notice I'll put only the move inside the repeat. So repeat 10 times. We're going to move I'm going to say here move one step, then wait for a tenth of a second. That would be 0.1. And move another step. And actually, let me repeat this 100 times. So in essence, we're moving 100 steps, but where it's going to take us 10 seconds to do this, in theory, right? So notice it's moving. It's much slower now because we're stopping it. This waits a tenth of a second before it loops back and moves a step, wait a tenth of a second, loop back, and it does so 100 times. And if you multiply the 100 loops times one step, that's 100 steps. If you multiply the 100 loops times 0.1 seconds, that's 10 seconds. So it moves 100 steps in 10 seconds. And if I click on the flag, it moves it back to its original position, and it moves 100 steps in a tenth of a second. Perfect. Now, there's a lot more in here. Notice that you can see a lot of what we have used in Python. There's an if or an if-else block. There's a wait until, so you can, and I also want you to notice the geometry here of that block. It looks almost like a diamond-shaped block. So you got to look for a diamond-shaped block that would fit in here. Notice in the go-to, there's an oval shaped, or in the repeat, there's an oval shaped. So if you go to operators, you can only fit these would fit in that if statement, whereas these would fit in these go-to statements or in the repeat. There's also ways to add, subtract, multiply, and divide. There's the AND conditions that we've used a lot of times in if statements, or conditions. The not, greater than, less than, equal to. These are comparing values. And so there's a ton of things that we can do. We can also make our own variables. At this point, we're getting to these variables where we can make variables that are holding a value that we're hoping for. Here we have, again, motion. We can turn, go to, glide, which basically makes it glide like as if it was flying. Change your x coordinate only so that it only moves sideways. You can set the x coordinate to a specific value. Change the y coordinate only. You can get the position, the current x position of the sprite using this. And then there's also things that the sprite can say. It can say hello. It can think, which I guess kind of puts that little bubble, the little bubbles on the little cloud. You can switch the costume because the sprite has costumes. So let's we'll look to that in a minute. Next backdrop, change. You can change the size of the sprite. Notice it's getting bigger. If I click here, if I click on the plus, it starts. But now I've changed the size, and so I would have to revert the size. I would have to go in here and set size to 100%, and it makes it small again. We can add sounds, although I've had students who had a little bit of a hard time with sounds, especially if they were imported. There's a way to upload sounds, but you can add sounds. Events, which is basically when I click on the flag. When you click on when you press the space key, notice here this allows actually for some user interaction. So suppose that every time you click on the space key, you want the sprite to jump. Now, jumping is a motion that needs to be somewhat simulated here. For example, we would change our Y so that it moves up 10 steps. We would increase the size to have it look like it's getting bigger. Change size by 10%. So that would make it look bigger. Then maybe we can wait a tenth of a second. So just wait a little bit. This is under controls. Every time you hit the space key, we'll wait for 0.1 seconds, and then go back where we change Y. Now it needs to be change y, not set y. Change y by -10, so make it come down again, and then change the size. You can duplicate this block, but it duplicates all the blocks below it. Notice I tried duplicating the purple one, but it duplicated everything below it. You can get rid of these by dragging and dropping here. And I believe if I put -10 here, let's try it. So notice if I click on the spacebar, it looks like it jumped, right? How do you make it jump higher? Well, you can instead of changing the going up 10 steps, you can go up maybe 20 steps and come down another 20 steps. So hit the spacebar. So it's moving, and at the same time, it's waiting to see if you click on the spacebar. Notice this is yellow, and this block is only yellow when I press on the space key. When its perimeter highlights yellow, it means that those blocks are activated. That's under events again, hitting the spacebar when the sprite is clicked, when the backdrop switches. So there you can detect when the backdrop switches. I also have students who had a little bit of a hard time with that. When you receive a message, now messages, broadcasting a message, and you can put here maybe I'll just add it here for now, but broadcasting a message, and you can make your message saying something like done. I'm going to move 10 steps, then I'm going to broadcast done. And then we can, in a separate block, we can say when we receive done, maybe we can do something. We can go to motion here, and we can do a few things. We can say, see you later. And then maybe we can, we should actually consider doing a function. So let's say that I want to run this code here, the set size, and go to 0, every time we kind of want to start. So I'm going to create a my block, and I'll call this the start block. And the start block, you can add inputs. These are like parameters that can be either a number or text or true or false. For now, I won't add any inputs, but look, we can define this block, and we can take this code, put it in there. Every time we want to start, we're going to set our size back to 100% and go to 0, which is the center. And then I can say, when I click on the flag, start, so execute the code and start, and then move 10 steps, broadcast you're done afterwards. And when you receive that broadcast that you're done, you're going to say, see you later, and then we're going to re-execute the code start so that it goes back to 0, and its size goes down 100%. Notice it's moving here for 10 seconds. Notice that it's highlighted yellow, and then it will eventually stop, which makes us then get to this broadcast message. And when you receive done, so broadcasted the message done, it was received. So that means when that message is broadcast, it's sent out. Say see you later, and then execute the code and start in this block. So it goes back to 0, resets the size to 100%. I never clicked on the space bar, so this code was never activated. Okay, this is just, I know it's a lot, but I want to kind of give you an introduction to what these blocks do. I haven't really talked about the sensing here. Notice here, key pressed is very similar to this block, but this block is standalone, meaning it's all by itself. This can be, you can put this inside an if statement. So if, and you could potentially put it at multiple locations. when you're touching a color. So there's a ton of things we can do. Finally, costumes. Notice every sprite has maybe multiple costumes. This sprite has two costumes, and basically you can, if you switch really quick between costume 1 and costume 2, it almost looks like the sprite is walking. If you pay close attention over here, that's costumes. You can add sprites. Oh, right here. Or you can choose a costume. Excuse me, this is to choose a costume. You can add sprites over here. Choose a sprite. There's a ton of sprites. There might be ways to upload yours. I haven't looked into that just quite yet. You can also choose a backdrop. And there's your backdrop. And the backdrop itself, well, in this case, it only has one backdrop, right? But it might be also have multiple backdrops. If I click, oh, I don't want to do that. If I click on the sprite, notice here it changes to costumes right here. Whereas if I click on the stage or the backdrop, it changes to backdrops. And you can actually write code for the backdrop as well, although I don't quite recommend that. I would you're going to be writing code for each sprite that you add. So this is an introduction to Scratch. There's a lot going on, but I hope that after working with Python for a few months now, that you can basically you can see how this is a little easier than working with Python in terms of using loops. The repeat 100 times is a loop, using if statements that I have not included in here that I will. We'll be building our own game as we proceed here, and then using a lot of logic to make a game.